Spur gear designing and weight optimization. Abstract: in this paper, we are designing and optimizing of gear for event SAE Baja Transmission. The given values of forces, torque, and factor of safety of gear are calculated in accordance to custom vehicle. The gear is designed using SOLIDWORKS Toolbox. Gear weight is optimized by material removal from specific region. After it, simulation on SOLIDWORKS and ANSYS is done giving input values from calculation. The result shows the difference in weight and factor of safety between optimized and unoptimized gear models. Introduction. Gear is used to gain mechanical advantage in power transmission. Gears of different types: spur gear, helical gear, bevel gear, worm, and wheel gear. Gears are commonly used in transmission of automobiles via gearbox. Transmission assembly are stated: simple gear train, compound gear train, planetary, etc. Weight of gears in gearbox becomes a constant factor of vehicle weight as whole. In college projects like SAE Baja, Supera, etc., the basic knowledge of transmission is seen by an engineer skilled to design a gearbox of required strength and maintain lightweight. The vehicle this gear is designed for use as a engine power source with CVT. Objective: to choose material of high strength. To calculate the theoretical forces on spur gear by conventional formulas. To model the spur gears on SOLIDWORKS using Toolbox spur gear. To remove material and optimize weight of spur gear. To simulate gear on SOLIDWORKS and ANSYS. Analysis. Theoretical analysis. Gear material. Material for gear is chosen based on yield strength of material. Materials commonly used are AISI 4340 and 353, etc. We have taken AISI 4340 for its high strength. The properties are as in Table 1. Spur gear nomenclature. Basic dimensions of gear are given. Module, M, equals 2.5. Number of teeth, Z, equals 59. Pitch circle diameter, D, equals M** Z equals 147.5 mm. Width of gear, B, equals 20 mm. Output shaft diameter equals 36 mm. Calculation of tangential force. The two components of net force on gear tooth are, radial force, Fr, tangential force, Ft. The only force responsible of gear rotation is Ft, calculated below. Ft tangential force applied on gear tooth/teeth. Ft equals 2*mt/d1. Ft equals 2,451,147.5. Ft equals 6,101.6949 N. Calculation of beam strength of gear teeth. The resistive force offered by gear tooth is calculated below. Fen resistive force of gear tooth. Sen allowable permissible stress of material. SUT ultimate tensile stress of material. Sen equals SUT/32. Fen equals Sen *BYM. Fen equals 1110/3, 20 p. 0.175/0.95/59, 2.5. Fen equals 9235.0843 N. Calculated factor of safety, FOS. Factor of safety is calculated. FOS equals Fen/Ft. FOS equals 9235.0843/6101.6949. FOS equals 1.51. Gear designing. For gear model, we take a standard spur gear from SOLIDWORKS Toolbox. Assign the module and teeth number. The software will generate a gear using global equations. We optimize it according to design using static simulation. For simulation, the center hub is fixed fixture and tangential force is applied on teeth for worst condition possible. Simulation of gear on SOLIDWORKS Fig 2, 3.